Hey everyone, Multipro. So glad that you're here to learn some Algebra 1. Today we're going to talk about open sentences. So there's going to be two things we're going to be talking about. One is equations and the other is inequalities. So we're going to solve an open sentence equation. That's our first goal. And our second goal is to solve open sentence inequalities. I hope that this helps you with your homework and helps you prepare for your next test. And I'm looking forward to showing this with you. But today we're actually going to have quite a few definitions, so let's go through these. Okay, the first definition, what is an open sentence? What is an open sentence? Is that where you talk but you don't finish your sentence? I don't know that is, but maybe it is in the grammar world. We're talking about math today. So this is a math statement with one or more variables. Remember, variables are like those letters and stuff that we have that we plug in numbers in for some time. And let's cover another one. Let's talk about what's a solution. Solution. A solution is a replacement value. And we'll kind of show what this means with an example a little bit later on. And then we have also another definition today that we need to know. What is an equation? So this is a sentence with an equal sign. Anybody remember what an equal sign looks like? It's two horizontal lines on top of each other of the same length with a little distance in between. So yeah, they look like this over here on the right. That's an equal sign. The next term we need to know is replacement set. Replacement set. Okay? All right, so a replacement set, this is a little bit of a long definition, so hang in there with me, and you can always pause and rewind the video if you need to. This is a set of numbers from which replacements for, they got way over there by itself, for a variable may be chosen. I hope you can read my handwriting. Okay, and now let's talk about another thing, a set. A set is a collection of objects or numbers. We have so many definitions, I gotta scroll up. Let's do another definition. Solution set. So now we're plugging together two definitions. Solution and set. So this is a set of elements from the replacement set. That make an open sentence true. Now this is a whole bunch of definitions, and it's quite important to understand what these definitions mean. So let's look at some examples using these definitions. Okay. So let's say that we have a solution set for equation and our replacement set. Let's say that our replacement set is 0, 1, 2, and 3. Okay. And so we're going to plug that into an equation. And our equation is going to be a squared plus 4 squared equal to 5 squared. And this is a very interesting equation that I have here. And we'll see why a little bit later. So we're going to be looking to plug in these values into A. Okay? So let's draw us a little table. Ooh, all right, we want columns. All right, we need rows. And let's do one more row. So we need a little bit longer columns. All right. So here we're going to put A. And we're going to say A is 0, 1, 2, and 3. All right. Now we need to put our equation. Our equation is this. A squared plus 4 squared equals 5 squared. And then over here we're going to have our final equation once we solve the equation. And then lastly, we want to know if it's true or if it's false. Okay? So let's plug in 0 for A. So 0 squared plus 4 squared, let's go ahead and solve this part. 16 equals 25. So 0 squared is 0. 0 times 0 is 0. 0 plus 16 is 16. Is 16 equal to 25? And it is not. So this would be false. Whoa, that's not true. Okay. Now, let's try with a 1 in for the A. So we have 1 squared plus 16 equals 25. Maybe you kind of see where this is going now. All right, 1 squared is 1 times 1. 1 times 1 is 1. It's like looking at itself in the mirror. So then, this will be 17 is equal to 25. Is that true? That's false. That's false. Man, let's try this other part of the replacement set here. All right, let's try 2 squared plus 16 is equal to 25. Notice here that we have 16 here, we have 17 here. So the number's getting bigger, so we're getting closer to 25. So let's see if we get to 25 this time. 2 times 2 is 4. 4 plus 16 is 20. Is that equal to 25? No, that's false too. I'm not sure why it drew all across there. I'm supposed to do this. There we go. All right. So let's try the last part of the replacement set. And that's the number 3. And we might have all false or we might have some true. Let's see. So we have 3 squared plus 16 equals to 25. 3 times 3 is 9. 9 plus 16 is 25. Is 25 equal to 25? Yes. So this one is true. So why is this interesting? This is just something on the side that you may learn later. There's this thing called the Pythagorean theorem. And basically, if we were to look at a triangle, and this is called the hypotenuse, and we call these the legs, or at least I do. We use this quite a bit because this is the same shape as a fillet weld, which you maybe don't know what that is. That's okay. So the way that this works is this is side A, this is side B, this is side C. And we want to find the length of one of them. Well, they have this relationship that's A squared plus B squared is equal to C squared. Well, what I did up here was I had A squared plus 4 squared equal 5 squared. So this is actually a 3, 4, 5 triangle. So you could always do this as a multiplier of each other. So say when we'll do 3 times 4. So we could do 12. 4 times 4 is 16, and 20. 5 times 4 is 20. So this always applies. It's a very interesting theory and trick. So let's move on. Let's look at using PEMDAS. All right, so we have 0 plus 3 times 12 over 1 times 7 minus 0. Okay? And remember, we have to solve the parentheses on the top first and then parentheses on the bottom. So I think we have a parentheses on the bottom. The top one's actually a multiplication. We could rewrite this if we wanted to as 3 times 12. So then let's do 0 plus 3 times 12 over 1 times 7. All right, now the next thing we have to do is multiplication. And we want to solve the numerator by itself and the denominator by itself. So let's do 0 plus 36 over 1 times 7. All right, now we have multiplication on the bottom. 0 plus 36 over 7. So then we have 36 over 7. All right, so then we could change this from a mixed fraction, or from an improper fraction to a mixed fraction. We could do that, right? So we learned this last time. All right, so these are equations. Remember that they have this equal sign. Let's look at something that doesn't have an equal sign, an inequality. Inequality. So now we have no replacement set, and we want to find when something becomes true and not true. So we are going to have the variable b. Okay. And we want to look at when it's true and when it's false. Okay, and our equation is b squared minus 4 times 1 times 0 is less than or equal to, no, just less than. So there's different symbols. Let's talk about these different symbols actually. We have less than, we have greater than, we have less than or equal to, we have greater than or equal to. Okay, so you have an angle shape. And then for the ones that are that or equal to, meaning the part on the left, it has this relationship to the right. We can always imagine this as like an alligator. So an alligator always wants to eat the bigger part to make it smaller. So the alligator's mouth is got some sharp teeth here, and he's trying to eat the other side to make it smaller. Okay, so the greater than is on the left, and in this case, greater than is on the left and the smaller is on the right. But it could be equal to. So that's what this line here, this horizontal line, this means that it could be equal to. So it's less than or equal to in this case. All right, so in this case, we have a less than sign. So that's what we have over here. All right, let's just plug in some numbers. 1, 2, and 3. We're making up our own replacement set here. So let's try b of 1. So let's say 1 squared minus 4 times 1 is 4. 4 times 0 is 0. 1 minus 0 less than or equal to 9 is 1 less than or equal to 9. That is true. 1 is less than 9. Did I say you're equal to? I might have. This is only less than. Okay, now let's try. We'll see if this one is true. 2 squared is less than 9. So 2 times 2 is 4. 4 is less than 9. So we're still true. But you notice the number is getting closer to 9. We first had 1, now we have 4. Let's do 3 squared. Is that less than or equal to 9? 9 is less than 9. 9 is not less than 9. 9 is equal to 9. 9 equals 9. So this statement then is false, that 3 squared is less than 9, because it's 3 squared is 9 and 9 is less than 9. Okay, great job. Let's keep moving here. Now I want to solve an inequality. So let me show you the inequality I want to solve. I want to solve 1 plus 3y is less than or equal to 7. So how do I solve this? So what I'm doing is I'm looking for what is y. What values could y be that makes this true? We want to make it true. Okay? And we're going to deal with integers here. So let's create a table. And we're going to have 1 plus 3. Whoa, that is not a 3. 1 plus 3y is less than or equal to 7. And we want to write the inequality that we solve over here. And then we want to know, is it true or is it false? Okay? So let's start with 0. And then we'll do 1. And let's do 2 for the replacement set. And then we'll finish off with 3. So 1 plus 3 times 0. I struggled writing 3s. And I lost this. 3. So this is 3 times 0 is 0. So 1 is less than or equal to 7. Is 1 less than 7? That's true. Is 1 equal to 7? No, that's not true. But only one of the two have to be true. that has to either be less than 7 or equal to 7. So then it is less than 7, so this would be a true statement. Because when it has less than or equal to or greater than equal to, it only has to be less than or equal to in the case of less than or equal to, or it has to be greater than or equal to for the greater than or equal to. Not both have to be true, only one has to be true. Okay, let's try plugging in a 1. 1 plus 3 times 1 less than or equal to 7. So this is 3 times 1 is 4. 4 plus 1 is 5. 5 is less. Oof, I'm getting a little rough with these numbers here. 5 is less than or equal to 7. That is true. We have a true statement here. Let's keep going until we find something that's false. So 1 plus 3 times 2 is less than or equal to 7. 3 times 2 is 6. 6 plus 1 is 7. 7 is equal to or less than 7. So is it less than 7? No. Is it true that it's equal to 7? 7 is equal to 7. So this is also true. Well, now that we've reached that we're equal to, probably when we add in this other term, the numbers keep getting bigger. If you look here, 1, 5, and 7 is getting bigger as we go down. Well, we've already reached 7. So now we will probably be greater than 7. Let's see what happens. 1 plus 3 times 3 is less than or equal to 7. 3 times 3 is 9 plus 1 is 10. 10 is less than or equal to 7. Is that true? No, that's false. It's a great job there. Let's do one last problem. Okay. Let's say if, whoa, my screen's moving. If 3x is less than 1, find possible values of x. So how do we do this? This is an inequality. This is not an equal sign. It says 3x is less than or equal to 1. Okay. So let's write this down. 3x is less than or equal to 1. So this is the same as 3 times x. So if we divide by 3 on both sides, so let's divide this by 3 and this by 3. What do we get? We get 1 times x is less than or equal to 1 over 3. This is the same as saying x is less than or equal to 1 over 3, 1/3. So what values are possible for x? 1/3 is possible. Is 2/3 possible? No, 2/3 is greater than 1/3. This can only be less than or equal to 1/3. What about 0? Yeah, 0 is less than 1/3. What about negative 1/3? That's also less than 1/3. So all possible values of x are any value that's less than or equal to 1/3. All right, I had a great time with open sentences with you. I hope you learned some things, and if you need to pause or rewind the videos, be my guest. Make sure that you understand these topics. If you have any comments, leave them. If you want to subscribe, so that way you can find out content for future subjects. It's been a great time.